Hello everyone, welcome to another video where today I will very briefly go through something that I found the other day in the community tab on YouTube. It is from Awake Souls, and it is rather funny to me. So I stumbled over this post first. I realized then that a couple of days before that they have already talked about that, but I'm going to stick to these two because they illustrate the point that I would like to make the best. So He says that finding out Earth's coordinate system projected to scale in 3D is an American football, which would be extremely funny, particularly for Americans. But of course, this is not the case. The Earth is a sphere, as we know. But I would like to talk about what is wrong with this picture here, right? And so what you can see from the outset here is that the scaling of the y-axis in this case, this is the x-axis, this is the y-axis, is not mentioned anywhere. So it could be, you know, increasing, decreasing, linear, as they have plotted it here. It is linear, which of course is not the case on a globe because it would distort the equidistant lines of latitude. The same happens here. We'll go into all of what I mean in more detail in just a bit. Just so you know, I'm not making this up. The NOAA here, under the question, what is latitude, states clearly that no matter where you are on Earth, latitude lines are the same distance apart. And you can already see from this picture here that the distance between this line and this line is less than the distance between, let's say, this line and this line. Something isn't adding up here. So I'd like to briefly talk about that in terms of one of my beloved presentations. So the first question, this is just for me, did it ever occur to you that this could also work on a sphere? Because you're making yourself look really stupid here, really silly rather. So what you did here is you spaced the lines of latitude linearly in the y direction, which is not what is going on. Did you try to fit it to a sphere? So I made myself the effort on a train ride home, or to my parents rather, for Christmas on the train ride. I decided to, you know, do something about it. So I modeled it out here in a linear fashion, and we see that this looks very similar. So I plotted the latitude against the nautical miles per degree, and indeed, if you do that, it does indeed look a little bit like a football. Now, the thing that gets me here is when you do that, you lose some of the things that we know to be true on Earth, right? For example, that the angle between the lines of latitudes are the same. The angle change between 70 and 50 is the same as for 40 to 20, or from 30 to 20 should be the same as from 80 to 70. But this clearly isn't the case. So I made this orange angle here, right? And without measuring it or anything, you can see that the orange angle here is bigger than this one. So already this can't work. I did the same with distances. You can see the same length of violet, the violet line here. You can see is this length up here, and if I put it up here, it is too short to cover the distance between the 2 points here. So clearly 10 degrees then wouldn't be 10 degrees of latitude. This wouldn't work. This is skewed. What is linear, though, is the projected distance on the y-axis by design, kind of, right? So I'd like to here, if you look at an actual sphere, you can see that the projected distance decreases with latitude. So you have this distance here, and it's a little bit smaller. You can't really see it. It gets a little bit smaller again, and so on until the projected distance between, in this case, 75 and 90 is really tiny. Okay, so how should this work on a sphere? This is the education part for you, Awake Souls. This is free education. First of all, I showed you the quote already from the NOAA. You can read it again if you want. But how should this work on a sphere? Approximately, because we're just talking about a sphere. No spherical axis. Just a sphere. This is completely sufficient for what we're doing. So the sine of the as in the sinus, we would say in German, is of the latitude in radians is the linear projected distance of the latitude lines. You can see that from the polar coordinates, right? The y-axis, which is what we're doing here, is r times the sine of the angle that you have. and r in this case being the radius, but this is not important as we're just talking about the projected distance. We can ignore the radius. And so I did that in Python. This is what it should look like, which looks awfully close to sphere, if you ask me. Now, I didn't make any efforts to check if this is that this is perfectly spherical, as this is only a quick visualization to show Awake Souls where he's wrong. But you can see that this fulfills the condition that we have, that the lines of latitude have a different projected distance from each other. And you can also already kind of see that the linear distance between them on the surface of this curve here will roughly be the same between the 2 points. I checked, they are very, very similar. Of course, not perfect because I'm only doing the approximations. And now I'd ask you, Awake Souls, can you guess where the data that you have provided fits if I project it like that? Oh, well, would you look at that? So almost as if this data could fit a sphere. Bizarre. Funny how that works. So, yeah, I'd like to, you really don't understand. You haven't made the most basic effort to represent your opponent's argument correctly. Because you don't get it, in my opinion. You don't get it. You also clearly don't get geometry. Could you maybe try? Could you put up a genuine effort? Oh, forgot that you're a flat earther, so you can't. So thanks, Awake Souls, for this amazing evidence that the Earth is indeed a sphere.